Okay, hey there, PreCalc. It has been a little bit. Sorry, I was just not all together there last week. Just was unmotivated, but I'm back. I'm good to go. Everything's fine with me. Hopefully, everyone's doing good out there as well. So we're gonna do 8.2 into two different parts. Part one, I think, is the way easier selection here with addition and subtraction, and then we're coming in tomorrow with multiplication. So let's get through some addition and subtraction of matrices. But we're going to start off with some basic definition of matrices in general. We can call some matrix just matrix A, and you could denote its components A sub ij. And I think, as we'd seen before, we can label it so that it is, n by m matrix here. And that would kind of be its bigger look, even though you can just denote that's what its components are. So for example, if we have a little 2 by 2 matrix here, this little square matrix, and we were told that these two matrices are in fact equal to one another, the only way that could be is if that first term in this matrix A11 would actually be 2. That means A12 would have to be this -1, A21 is -3, and 0 may seem like some no-duh statements, but it is important to make sure we have that understanding moving forward in the rest of what we're going to be looking at here. Okay, so to get to the addition and subtraction specifically, you can only add and subtract two matrices if they're of the same order. That's that m by n order. The rows and columns have to be the same size. Otherwise, their addition or subtraction would result in some undefined outcome, something that we can't actually do. So looking at this first one, we have two 2 by 2 little square matrices. Adding these together, the addition is very intuitive and what you would think of it. So I'll kind of write it all out here. It would be like for that first term, if you said what's -1, because that's in the first spot, and you would then be adding it to 1. The next one over here, going across, we would have 2 plus 3. The next one would be 0 plus -1. And then the last one, I don't have a different color, so we're going black, 1 plus 2. So it'd be like adding all of these, and that final outcome here would look like we have a 0, -1, 5, and 3. So kind of the intuitive way that you may think to go through it, but just to kind of show you that's what it is. It doesn't matter if we even have these 1 by 3 matrices as well. So notice we're just going to add the top ones, 1 and -1. We're going to get a 0, -3 plus 3, 0, and then here we're left with a 1. And so that means the resulting matrix has to have the same size as kind of the 2 where it comes from. In this case, if we're adding them together, you would be thinking the 2 and the 0, the 1 and the 1, and then the 0, and there's not one here. And this is where you should be scratching your head a little bit and saying, oh, what's going on? Then you should be noticing, oh yeah, they are not the same size, right? We need that same m by n order. Since they are not here, this is undefined, we can't do this. And kind of one nice extension off of this for matrices is what's called scalar multiplication. I know I said we're getting into multiplication tomorrow, but that's of like two different matrices, like A times B. Here, it's just like, what is 2 times this matrix here? So 2 times 1, 2, 3, 4. So if we're going to go through and see what that is, 2 here, 6 here, 4, 8. So also kind of the intuitive way that you think is you multiply that 2 by every single term in there. Okay, we can now start getting into some almost like equation looking parts of matrices. So we have 3 times this first matrix minus this second matrix. And just kind of like our PEMDAS rules that have followed along before, same thing applies here. We can't do the subtraction and then multiply that 3. We do have to multiply by this 3 initially. So if we're multiplying by that 3, to start off, we're getting what? 6, 6, 12, -9, 6, 0, -3, 3, and 6. Right, so a lot of those basic math skills here. Definitely easy to make one little mental math error, so try to stay vigilant. I might make one as well. I think I'm good so far, though. And now we're taking these two, and we haven't done a subtraction yet, but subtraction is just as you would think. We're matching up the parts that go together and subtract them. So we need 6 minus 2, and that's going to be 4, 6, 12, negative 9 minus 1 is negative 10. We're subtracting that negative 4, it's now positive. Mm-mm. 6 minus 2. And I think if I check here that I did get them all good, haven't messed up mental math yet. So just showing you that even kind of these basic equations, how you'd see them would follow maybe how you think. And there's a bunch of properties that we can now define here. They're all properties that we've seen before. These are the names that when I was taking math at the beginning, I always kind of confused them in my head: commutative, associative, distributive, and just kind of knowing which one's which, to show that they also work as well with matrices. So if you're adding any matrices, A plus B, that's going to be the same as B plus A, the commutative property. If you're adding 3, so A plus B plus C, even if you added that B, C first and then the A afterwards, that's the same as adding A and B and then C later. It doesn't really matter which one you add first. Now introducing some scalar multiples. So C and D are numbers, let's say like 2 and 3. So 2 times 3 times some matrix A, it's going to be the same as 3 times the matrix A, then times 2. So also matrix notation, lowercase letters tend to be scalars. If they're capitalized, then that means it's a matrix. Kind of tell the difference in here. The identity, kind of the no-do one, 1 times a matrix is just going to be that initial matrix A. Now if we have a scalar multiple and we're multiplying it to the addition of 2 matrices, you could multiply each by the matrices first and then add those together. Or you could, add the matrices and then multiply. And then same thing if you had 2 scalar multiples. You could add them together and then multiply by a matrix, or distribute that and multiply them to the matrices first before adding. Whew, long-winded there. Let's do an example here. So here we have 2 matrices that we're going to add together and multiply by 3. And I'm going to take you through both different paths here. So let's do the one where we actually add the matrices first. So that 3 is still here. And adding these, we have 2, 7, 8, and negative 2. And now if we multiply those by 3, what are we left with? 6, 21, 24, negative 6. Feel good with that? Okay, let's try it the other way as well, where we actually multiplied it first and then kind of carry it through. So, or we can do it this way. Multiplying them first, we have what? Negative 6, 0, 12, 3. And then 12, let me not zone out here. Negative 6, 9, 21. Great. And that's going to bring us to 6, negative 6, 21, and 24, which is not shockingly the same thing. Same. No different. Okay, so that's a good thing that it ended up being that way. And the last little thing I want to do with addition and subtraction here is they can just give you general equations here. So they could say solve for x given some equation 3x plus a equals b. Keep in mind, since it's a capital A and B and the x is also capital, this is all to indicate that your answers you're looking for are in fact going to be variables. Or matrices, sorry. The x is the variable, the a and the b are the matrices that we're looking at. So a good starting point could be just to solve for x, kind of how you would in a basic algebra or pre-algebra course even. So we would subtract that a over initially, and then we would divide by 3. which you could think of as just multiplying by 1/3. And so our final solution should have this form. So let's plug this in now all of a sudden to the matrices that they gave us here. So 1/3 times, this is B minus A. Right, so just took the B, put it there, A, put it there. Let's do this subtraction first, because looking in here, I don't want to end up with some of these ugly fractions and have to add and subtract those as it is. We'll deal with as little fractioning as we can. Fractioning, that's a word, right? That's how English works. So -4, 2, -2, and 6. And now we're going to take 1/3 of all of these. And so the nicest way to just do that, leave it as fractions, that's fine. Unless, of course, it divides nicely like that one does. And that is going to be our answer there in actually solving an equation here. So like I said, this is part 1. Part 2 is going to be some multiplication, which is definitely more difficult and involved in explaining. This should get you through most of the homework here in 8.2, but like I said, I should come back tomorrow with part 2. Definitely got the motivation kick here today for whatever reason, so I'm going to keep riding that train. Okay, bye guys. Stay safe.